everyone. In this video, we are going to learn what are relational plots, and following are the topics that we are going to discuss. Firstly, we will understand what are relational plots, then we will learn how we draw it in a Seaborn library. After that, we will discuss the relational plot function, scatter plot function and line plot function. So let's begin with the understanding what is relational plots. You all know that visualization is essential as it enables human to recognize the trends and pattern in data. And you also know that the statistical analysis is the process of discovering out how the variable in the data set related to one another and how they interact. So in the Seaborn library, the statistical analysis is done with the help of the relational plot. We can say that the relational plots are used to visualize how the data points are statically related to each other. So with this we have understand what is relational plot. So now we will learn how we draw it in a Seaborn library. So to draw the relational plots we have a three function. First one is relational plot function, the second one is scatter plot function, and the last one is line plot function. We will discuss each of these functions in detail with the help of examples also. So let's start with the relational plot function. Firstly, I explain you what this function does. So the relational plot function give us access to the several other axis level functions that demonstrate the connection between the two variable using the subset semantic mapping. And the syntax of this function is Seaborn dot relational plot, and in parentheses we pass different parameters. I will explain you all the necessary parameters. So the first two important parameters are x and y. These are the data points that define that the x and y axis location. The next one is hue, and it is a grouping variable that will produce component with the different colors. The second one is size. It is also a grouping variable that produce a components with different sizes. The third one is style, and it is a grouping variable that will produce components with different style. The fourth and the fifth one is a row and column. These are the variable that specify subset for different plotting facets. The next one is kind, and it specifies what kind of a plot you want to draw. It has two options, scatter or a line. And the last one is data. It basically defines the data set that is being used. So now we will see the different example related to this relational plot function. So here is the example related to the relational plot. Firstly, we will learn to import the libraries and reading the data set. So here you can see that firstly I import the two necessary libraries. The first one is Seaborn as SNS, and the next one is matplotlib with the pyplot module as PLT. After that, I want to read the default dataset. So I call the load underscore dataset function, and as an argument I pass the default dataset named as a taxis. The dataset gives us information about the passenger who have traveled in the taxi, whether they left the tip for the driver or not, and their pickup and the drop off date and time, the number of passengers, distance travel, fare, toll, total, pick up and the drop off zone, and also the pickup and the drop off brow. And it also talks about the payment method and the color of taxis used by the passengers. So here you can see that after that I call the head function as I want to print the top 25 entries of the dataset. So I pass 25 as an argument and print it by using the print function. Now I execute this cell and show you the output. So here you can see that we have a pickup column, drop off column, passengers, distance, fare, tip, toll, total, color, payment, pickup zone, drop off zone, pickup brow, and the drop off brow. Now we will move ahead and learn the basic relational plot. So here you can see that firstly is select the style. So for this I call the set function to set the appearance of the plot, and I pass the style as a keyword argument to it and set its style to the dark. Then you can see I call the relational plot function as I want to draw a relational plot to visualize the data between distance and the data point of the Texas data set. So here you can see that in the data keyword argument, I pass the variable data underscore set, and from the above, you can see that the data underscore set variable load the Texas data set. So it means this data is equal to the Texas. Then I want to add a label at the plots at the x-axis and the y-axis also. So I call the x-label function and the y-label function, pass label as an argument, and additionally I want to change its font size, so I pass keyword argument font size to the both of the function, set its value to 12, and to change its color also I pass color as a keyword argument and set its value to B, which means blue. Next I want to add a title on the plot, so we get to know what this plot represents. So I call the title function, pass title as a keyword argument, and addition to this I also pass the font weight keyword argument as I want to change the font weight of the title, and I set its value to bold. And last I call the show function as I want to display the plot on the user screen. So now I execute this cell and show you how the relational plots look. So here you can see that this plot represents the distance versus tip, and here the y-axis represent the tip and the x-axis represent the distance, and this is the relational plots which represent as a circle marker. Now we will learn the grouping data points based on the category, and in this case I use the category as a color. Now this time I again call the set function as I want to change the style of the plot, and I pass style as a keyword argument and set its value to text now. After that I call the relational plot function as I want to draw a relational plot between distance and the fair data point of the Texas dataset. Addition to this, you can see that I pass u as a keyword argument to the relational plot function as I want to group the color data points with the different colors. So I pass color as a value to the hue. Again, I want to add labels. So I call x label and the y label function. For adding the title, I call the title function. And to show the plot, I call the show function. Now I execute this cell also and show you how these plots look like. So here you can see that this plot represents the distance versus pair grouped by a color. So you can see that here it shows color, and under this color it shows that we have two colors, yellow and the green one. These are the color of the taxis. There are two color taxis, yellow and the green, and it shows how much distance is covered and how much fare it takes. So you can see that the red one circle represent the green taxi and the blue one represent the yellow taxi. So now we will move ahead and learn this time using of a color and the payment for determining the facet of the grid. So I again change the style of the plot. So I call the set function, pass keyword argument style and set its value to white this time. Then to plot a facet of the grid, I call the relational plot function, pass x value as a total, which means it take the column total as a x data points, y data points as a tip column, u as a passengers. Then I additionally pass, here you can see that the col, which means column, and I set its value to color, and then I pass row as a keyword argument and set its value payment. Then I pass the data and assign its value to data underscore set, and then I call the show function to display the plot. Now I execute this cell and show you how this looks. Basically it shows you the subplots. You can see that the first, here we have a subplot which shows that the payment equals to credit card and color equals to yellow. It means this plot shows the payment done by the passenger is by using the credit card, and the color of the taxi in which the passenger sit is a yellow, and it shows, here you can see that the x-axis represent the total and the tip, what the total amount the passenger pay and what the tip amount they paid out of the total. The next subplot represent the payment as a credit card but the color as a green. You can see that here the rows represent the payment. It means the first row represent the credit card payment, and here you can see that column represent the colors. It means the color is represented in the form of a column. The first column represent the yellow color and the second column represent the green color. And you can also see that here we use a hue method which is according to the passengers. So here are the passenger hue which shows with a different color from 0 to 6, and these are the shown in the plots. So now the second one is payment method is the cash and the color is yellow. In this case you can see what the total amount the passenger give and what the tip is. And the last subplot is payment type is cash and the color of the taxi is the green, and the total amount paid by the person versus the tip given by the passenger. So from these plot you can easily say that the minimum number of a person sit in the green taxi or giving a cash payment, and you can conclude also that the maximum passengers sit in the yellow taxi and pay with the help of a credit card. So now we will learn grouping data point based on the category, and in this case we will choose color and a passenger. I again change the appearance of the plot by calling the set function, passing the style as a keyword argument and setting its value to the dark grid. Now I call the relational plot, set its x value to the distance column, y value to the tolls column, hue as a color, and here you can see that I have a size as an additional keyword argument. Now what this size does? Basically, it groups the passenger data point with the different sizes and then the data. And after that, I also pass the x label and the y label function of the pyplot module as I want to add labels, and title also as I want to add the title on the plot, and last I call the show function. Now I execute and show you the output. So you can see that this plot represents the distance versus toll grouped by the color and size by the passengers. So the x-axis represent the distance, the y-axis represent the toll. The color of a taxis are two, yellow and the green. The blue dots represent the yellow taxi, the red dot represent the green taxi, and the passengers are represented with the help of these different sizes of the dots. So the minimum size of the dot represent that there is a 0 passenger in the taxi, and the maximum size of the dot represent that there are a 6 person in the taxi. You can see that here we have a point, a blue color marker, which means it is a yellow taxi having a passenger value near about 4 to 5, and it paid a toll near 0.9 point something, and its distance is between 28 to 29 kilometers something. So you can easily predict number of passengers, the which color taxi he used, and what the distance he covered, and what the amount of tolls they give. Now we will learn how to use the relational plot with kind parameter, and in this case we use the line and the grouping data point based on a category, and in this case we use the color. So here I again change the style of the plot by calling the set function, passing style as a keyword argument, set its value to white grid. Then I call the relational plot function, set its x value as a pickup burrow, y data points as a pair, hue as a color. Then I additionally pass a kind as a keyword argument to it. This kind argument tells what kind of the plot you want to draw. So I set its value to line, which shows that we want to draw the line plot, and then I pass the data as a keyword argument also. Then I call the x label and the y label function to add labels at the x-axis and the y-axis. Then I call the title function, and last I call the show function. Now I execute this code and show you the output. You can see that it represents the pickup versus fare. Y-axis represent the fare, x-axis represent the pickup burrow, and here the blue line represent the yellow taxi and the red line represent the green taxi. So here you can see that there is some shaded region around the lines. So what is this shaded region in the Seaborn? Basically, by default, the plot aggregates over the multiple y values at each value of x, and to show an estimate of the central tendency and the confidence interval, this shaded region is used. This shaded region is used to represent the confidence interval. Now we will move ahead and learn to use the relational plot method with the kind parameter. In this case, we will set the kind value as a scatter and grouping the data points based on the category, and in this case we will use it as a color. So firstly I set the style of the plot by calling the set function, passing keyword argument style to it and setting its value to white grid. Then I call the relational plot method, set its x value to the drop of brow, y data point has a fare, style as a color, and a kind as a scatter, and data as a data underscore set. Also call the x label and the y label function to add labels at the x-axis and the y-axis. Call the title function to add a title and call the show function to display the plot. Now I execute this code and show you. This plot represent the drop off versus fare, and here y-axis represent the fare, x-axis represent the drop off brow, and here you can see that the color represent yellow and the green. The circle marker represent the yellow color taxi and the cross marker represent the green color taxi. So here we set the style keyword argument to the color. So this reason it shows the taxis in the different style, and the style is of the marker. It changed the yellow taxi to the circle marker and the green taxi to the cross marker. From the above two last example, you have seen that we have visualized different kinds of plot, line and the scatter, using the relational plot function, and Seaborn also provided us a separate function for visualizing these kind of the plots, and these function have some more functionality as compared to the relational plot. So next we will discuss about the scatterplot function and the line plot function.